Someone on our team spent the weekend writing a Pinterest scraper. They ran it on a board with over 2,000 pins and they got back 16 results. The script didn't crash, it thought it was done. That's not a bug, that's Pinterest working exactly as it is designed against standard scrapers. In this video, I'm going to show you why that happens and exactly how to set up Pinterest scraping that actually works. Watch this video to the end. I'll show you a clean Pinterest scraping setup, how to keep your IP and browser fingerprint clean so you don't get blocked, and how to get 2 GB of free proxies to start extracting data right away. Links are in the description. Here's the thing that most people miss. Pinterest is built entirely on React. It's a fully JavaScript rendered single-page application. When you fire a plain HTTP request at a Pinterest URL, the server sends back an almost empty HTML skeleton, a few script tags, a mounting div, and nothing else. All of the pins, images, titles, grid layouts, none of that exists until JavaScript runs inside a real browser environment. That is why Requests plus BeautifulSoup fails completely on Pinterest. The page content you want literally isn't there when you make the request. A quick compliance note before we go further. Pinterest's public boards are publicly accessible, so extracting data from them is generally reasonable for research use cases. Just check the robots.txt. Stay away from private account data and don't hammer the servers. Treat it the way a pro would. Also, Pinterest's official API requires a business account, a full video demo approval process, and then only gives you access to your own account data anyway. Not competitor boards, not search results, not public profiles. So, for any serious research work, scraping is the practical alternative. Let me be specific about what's on the table and what isn't. You can get things that are available publicly like pin titles, descriptions, image URLs, save counts, that's repins, source links, creation dates, board names, follow accounts, and search results for any keyword query. What Pinterest doesn't expose are impression data, click-through stats, analytics for accounts you don't own, private boards, and individual follower lists. The data you do get, like the saves, the links, the description, images, and boards, is enough for most research use cases. Save count is your primary engagement signal here. Let's clear up these 3 myths before we touch the code. Myth number 1 is a standard headless Chromium with a proxy is enough. This is not entirely true. Default headless browser signatures, the TLS fingerprint, the navigator properties, the missing hardware signals are well known to anti-bot systems. Pinterest can and does serve login woes or empty responses to unmodified headless browsers. You need a realistic identity, not just a proxy. Myth number 2 is more scroll equals more data. Honestly, this one trips people up constantly. Pinterest loads pins in batches on scroll, but if your scroll logic doesn't include deduplication and proper wait times, you end up with the same batch of pins repeated dozens of times in your output. Speed without logic gives you noise, not data. Myth number 3 is Pinterest doesn't really block scrapers. It's too open. Okay, real talk here. Pinterest absolutely has anti-block protections. If your request pattern looks non-human with Datacenter IP, fixed intervals, and missing browser signals, you will either get rate limited or you will hit a soft block, where the page loads but it returns stale, empty, or repeating results. Ghost listings are Pinterest's way of telling you that it knows what you are doing. So what actually works? If your target is Pinterest or any React or SPA-based platform, don't use raw HTTP requests. You need a real browser that supports JavaScript execution. Playwright is the right choice. It renders the full page, supports scroll simulation, and is actively maintained. If your initial page load is giving you only 25 to 50 pins from a board with hundreds, don't assume that's all there is because Pinterest uses infinite scroll. you need to simulate scroll events with deduplication logic and randomized wait times between batches. Without that, you're only ever seeing the first viewport. The extraction anchor you're working with is the data test ID equal pin wrapper div. Inside each wrapper is an A tag with ARIA label for the title and href for the pin URL and an image for the thumbnail. That's your structure. For Pinterest, residential proxies are the right call. Pinterest's detection systems flag data center IPs pretty aggressively. They see them constantly from automated traffic, so they're already suspicious by default. Residential IPs look like real users browsing from home. The trade-off is real. They're slower and more expansive than the data center proxies. That's just the cost of a higher unlock rate. If you're doing a quick one-time pull and do not mind occasional blocks, then data center IP and proxies might be acceptable. But for any ongoing workflow, residential proxies is the way to go. Now here's where it comes together. An anti-detect browser isn't just a regular browser, it's a tool that manages isolated browser profiles, each with its own spoofed fingerprint, canvas, WebGL, fonts, audio context, and hardware signals. Each profile is completely separate. There's no shared cookies, no cross-contamination, and critically, each profile integrates a proxy directly, so your IP and fingerprint are always consistent with each other. The tool I use for this is GoLogin, and this is how I set it up. Open GoLogin. In the left sidebar, hit Profiles, then New Profile. Name it Pinterest Scrape 01 or any other name that you want to name it. Go to the proxy field, paste your residential proxy credentials in. GoLogin reads the proxy's IP and auto-configures the time zone, the language, and location to match. You don't need to touch those settings manually, and that's important. A time zone that doesn't match your IP's location is one of the first signals a fingerprint check flags. Click Run Profile. When the browser opens, type iphey.com in the address bar. You want to see a green trustworthy result. What Iphey is checking is exactly what the Pinterest anti-bot layer checks. It checks the IP class, fingerprint consistency, WebRTC leaks, time zone match, and language match. Green here means your session looks like a real user before you've made a single request. If Iphey shows a WebRTC leak or a time zone mismatch, regenerate the profile. Take 10 seconds. Do not skip this step. Now you're ready to run your Playwright script from inside the browser or use the browser session directly. Here's a quick real example for you. An e-commerce researcher trying to map trending aesthetics in the home decor category. They ran a plain Playwright script from a data center IP with no custom user agent. Pinterest served them a login wall after the third request. No error, just a redirect to the sign-in page. And their scraper kept collecting the same login page HTML, thinking it was getting data. They didn't catch it until they opened the JSON output and found hundreds of identical empty objects. Here's how a clean setup prevents this. With residential IP, realistic browser fingerprint, proper user agent and config, and Iphey verification before you start. The login wall never appears because the session doesn't pattern match as automated. For image resolution, by default, Pinterest Grid View serves 236x thumbnail URLs. Rewrite the path to 736x in your extraction logic to get higher resolution image. Please note that the originals tag has been returning 403 errors increasingly in 2025 and 2026, so 736x is the reliable maximum you can count on. If you start getting 429 responses or notice that the page is loading but the pin cards are empty, you should suspect a rate limit or a soft block. Cut your concurrency immediately and add randomized delays between scroll events. Vary these delays between 2 and 5 seconds. And if you're on a data center IP, switch to residential. If your scraper has been running for a while and you start seeing the same set of pins repeating across different scroll positions, that's a soft block pattern. Pinterest is serving you a cached, stale response rather than a fresh result. Change your IP, clear cookies on your browser, or return to a fresh GoLogin profile. Here's the honest trade-off. Even a clean setup with residential proxies and a verified GoLogin profile doesn't guarantee zero blocks forever. It significantly reduces the risk of detection, but Pinterest regularly updates its detection systems. Anyone out there who's telling you that there's a bulletproof permanent solution to this is just overselling it. The setup I'm showing you here is what reduces it and not what completely eliminates it. One-time research pool versus daily monitoring. If you're doing a single research project, let's say mapping out competitor boards for a content audit, run it once, export to JSON or CSV, and you're done. If you're building an ongoing monitoring workflow that checks for new pins daily, you need to track last seen pin IDs and only track new content since your previous run. Running full board scrapes repeatedly at high frequency is exactly the pattern that triggers rate limits. Search scraping versus board scraping. Scraping Pinterest search results gives you trending content for any keyword query, which is useful for SEO research, trend forecasting, and identifying what's resonating in a niche right now. Scraping a specific board gives you structured competitive intelligence such as a brand's full visual strategy, their most saved pins, and which content links out to external pages. The technical structure is similar, but the data model and use case are different. For search, your entry point is pinterest.com/search/pins/?q your plus query. For a board, it's pinterest.com/username/board-name/. Both use the same pin wrapper selector for extraction. The 16-pin problem that we started this video with has one root cause, and that's Pinterest renders everything in JavaScript, so static scrapers see nothing. The fix is Playwright for browser-based rendering, proper scroll logic with deduplication, a residential proxy, a clean GoLogin profile verified on Iphey.com before you start, and randomized pacing so your session doesn't pattern match as automated. That's the setup that holds up. If you want to replicate this Pinterest scraping setup to get 40% off GoLogin and claim 2 GB of free proxies, click the link in the description or the pinned comment below. I will see you in the next video.